Okay, so let's first draw the situation that we have. This is quiz question number 3. I have two resistors that are 20 ohms and 30 ohms that are connected in parallel. So let's come down and we have these two resistors in parallel. And then they're connected in series with the third resistor. These resistors are 20 ohms and 30 ohms and connected with the 24 ohm resistor. I have a 36 volt power source. Total voltage is 36 volt. The voltage drop across the 24 ohm resistor, I need to find what that is. So to do this, I just dove right in and started simplifying the circuit. So that's always the first thing I do in these kinds of problems. I simplify the circuit. I have two in parallel, so I combine those two in parallel to turn them into one, so that my circuit will then look like this. Then I have two in series. Okay, so we call this R1, let's call this R2, and we'll call this one R3. So then this one, I would combine R1 and R2, I'll make this one R, subscript 1, 2. Yeah. And then I'll make this one, we'll say R3.
Can you go over how to combine things again?
I'm going
at some point. Okay.
Yeah, we're going to do this.
Okay.
We're going to combine it.
No, but like, in general, like other examples too?
Yeah.
Okay.
We're going to do example, let's see. We're going to do number 5, we're going to do number 61, we're going to do number 45,
okay, cool.
and number 62. Lots of examples. Okay, so I need to combine these R1 and R2 into R12. Yeah? These are attached in parallel. So if I'm combining resistors in parallel, do I add them normally or do I add them flippy-flop? I need to add them flip-flopped. So I have 1 over R12 is equal to 1 over R1 plus 1 over R2. So 1 over R12 is 1 over 20 plus 1 over R2 is 30. 1 over 20 plus 1 over 30. I combine those together. I get 1 divided by R12, and when I combine that, what do I get? I get 0.08. So is that R12?
Not yet. No.
No. What do I need to do?
Yet.
I need to flip it. I take the reciprocal. So when I take the reciprocal, I get R12 is equal to 12. Yeah. Okay. So now I can take that and I can plug it in right down here. R12 is 12. R3 is still 24. I can combine those resistors. These resistors are in series. Do I add them normal or flipped?
Normal.
I add these normal. So I can get, let's call it R123 equals R12 plus R3. So that's going to combine to give me an R123. So I'm combining them from 3 resistors to 2, and then from 2 down to just 1. So R123 is equal to 12 plus 24. What's 12 plus 24?
36.
36. So that's the total resistance in this circuit. That's the equivalent resistance. Okay? Now how do I take that and how do I start figuring out what I am actually asked? I'm asked the voltage drop across the 24 ohm resistor. I need to know the voltage drop in R3. So to figure that out, I kind of need to know how to go from here back to here. So let's figure out everything that we could possibly know about this situation. Just this one resistor. What things can I know? I know the resistance. What other kinds of quantities? Voltage. Voltage 1, 2, 3. What is V123? 36 volts, because I know there are 36 volts inside of this whole circuit. Okay. What else can I calculate? Current. I can figure out I from V equals I times R divide both sides by R, and I get I is equal to V divided by R. So I can figure out I, 1, 2, 3, is equal to V, 1, 2, 3, divided by R, 1, 2, 3. So that's 36 divided by 36. That should be 1 amp. So that's the amount of current that I have in this circuit. I have 1 amp. Yeah?
Yeah.
Okay. The way I approach these, I do these all the exact same way. You're going to see this as I keep doing more and more. I always break it down into one resistor. And then from that one resistor, I can calculate the voltage, if I'm usually given it, 36 volts, and I can calculate what the current is. So that's the current in just this one. So all of this works for this situation. Now I need to take this and I need to start working backwards. So I go back one step. I go from here up to here. I'm going from one circuit, I'm going into a series circuit. So it sometimes helps me to write down series. And then I write down what kind of variable I want to work with. If I want to work with either the current from the previous step or the voltage from the previous step. And I determine which one I want to work with by whichever one stays the same. If I'm in series, the current stays the same. If I'm in parallel, the voltage stays the same. Here I'm going back one step, I'm going into series. If I write series, then that tells me that current is the same. So whatever current I have down here is the same as the current I have here. Okay? So what is the current that I have down here? The current I have in 1, 2, 3 is 1. So then the current I have in 1, 2, I, 1, 2, is going to be 1 amp. The current I have in I3, in resistor 3, is going to be 1 amp. Okay? Again, that was going from the previous step, going back up. That's breaking them into series. In series, current stays the same. So I know what I's are. Do I know what R is? What's R12?
12.
12? How do I know that?
Because it says it right there.
I calculated it right there. Okay. And R3. What's R3? 24. How do I know that? Or I was given. Yeah. Either calculator you were given. Okay. What can I find? V. I can find V12 equals I12 times R12. So what's V12? What's 12 times 1?
13.
12 volts. Good thing I'm awake. Okay? And then V3 is I3 times R3. V3 is going to be 24 times 1, that's 24 volts. Okay?
I felt a lot better about this problem before I knew how complicated it was.
It looks like it should be easier than it actually is. Yeah. And I can notice something about the voltages. This is sometimes useful. I have 2 resistors here, right? The total voltage going through both of those has to add up to the total voltage of the circuit. Each one of those resistors takes some of the voltage out. So if I take 24 plus 12, that's 36. That's the total voltage in the circuit. So there are internal checks to make sure everything's consistent too. In series, your total voltage has to add up to be, all of your resistors have to add up to the total voltage. Good. And actually this question is asking, what is the voltage drop across the 24 ohm resistor? The 24 ohm resistor is R3. So I need to know V3. I just calculated it, 24 volts. I'm done. That's the answer to this problem. What if I wanted to take it further though?
Huh, you shouldn't do that.
I think I should. I think we should take it further and calculate another step back. So I'm going to go from here to here. So I'm taking these resistors, R12, and I'm breaking them up. am I going backwards? By going backwards, am I doing things in series or parallel?
Parallel.
This is taking them back to parallel. Voltage stays the same in parallel. So I want to work with voltage here. So I know V1 is equal to the voltage from back here is equal to V12. What was V12? 12 volts. So I know V1 is 12 volts. I know V2 is equal to V12. V2 is equal to 12 volts. In parallel, each one gets the same voltage. How about R1? What's R1? They gave us in the problem. It's 20 ohms. R2.
What are we trying to find again?
Oh, we're just going to calculate everything.
You just use that to find AM.
30 ohms. I is equal to V over R. We found that at the very beginning from Ohm's law. So I1 is V1 over R1. That's 12 over 20. 0.6. I2 is V2 over R2.
Someone trying to FaceTime you? That's a Facebook video. We should answer.
He's not home.
Look on our Facebook.
Probably my parents. I2 is 12 over 30. I2,
Turn the whole thing off.
0.4 amps. And it wasn't my parents, it was probably a courtesy call. Okay. So now I've calculated I1, I2, I3, R3, V3, R2, V2, V1, and R1. I know everything about this circuit. And it was systematic steps. Follow the same procedure every time I do one of these. The more you practice, the easier it gets. Any questions on this one? Yes?
How do we know that in a series current stays the same and in parallel voltage stays the same?
We've measured it.
Okay.
So it holds true every time you do it in a circuit?
Okay. That's for conductors and for resistors?
Capacitors.
Capacitors and resistors?
Yeah, for capacitors, we talk about charge. And charge is just flow of current.
Okay.
So they're the same thing. They behave the same.
Okay.
Yeah. Any other questions on that one? No? Okay. I can get rid of this. It's disappearing. Quiz question number 5. There were no questions, so it's gone. I did record it. Hopefully. Quiz question number 5 was 2 resistors that were attached in, oh gosh, how were they attached?
Parallel.
They were attached in parallel?
Yeah.
Yeah. Nope, they were in series.
Series.
Yeah. So something strange happened, and the grading was grading the right answer wrong.
Yeah. I wonder
Okay.
why.
My sample student got it right, and my sample student, when I took it as a sample student, it graded it, and it told me that this was the right answer. It told me 40 ohms, and said check. Yes, correct. How many of you put 40 ohms and didn't get the right answer? Yeah, I got a couple emails about that. I couldn't fix it till I got back from my conference in Mexico. Conference. There were a ton of PhDs there. I talked to 2 toxicologists, dentist, optometrist, a military drone developer.
I thought you should talk to the drone.
Yeah, I'll say you.
No, not just military.
Talk to the drone.
Okay, but I got back and realized this was the case. Okay, 40 ohms is the correct answer
Yeah, you said it.
because you have these 2 resistors Boom, boom, boom. Boom, boom, boom. One was, what was it, 10?
10, one was 30.
One was 30. They're in series. You just straight up add them. 10 plus 30 gives me 40.
If only life was this simple.
Yeah, so that's the correct answer.
Would that be so we all get hundreds?
That's simple when it's in series.
No, that's too easy.
Adding a circuit like this is way too easy to be on an exam.
No.
Okay. And since it was graded wrong on the quiz, it can't be on the exam. And since it was graded wrong on the exam, everybody gets a perfect score on the exam for chapter 27.
Yeah.
Okay?
Well, the problem.
Quiz.
You said exam.
You said exam.
It's on video.
It's on video?
Yeah.
I'm on video reverting my promise that everybody gets a perfect grade on the exam. Quiz. Chapter 27.
You said exam. It's on video.
You seem to think these things are binding. I can lose that video. Yeah.
Oh, was something like problem 3 with all the extra stuff you had to be like something we would see on the test?
Oh, absolutely.
Okay.
Or something more like problem number, oh gosh, which ones? 45, 61, or 62. But before we do those, let's do problem number 9. Problem number 9C. Does somebody want to read it for me?
49.
9C.
49C?
Number 9C. Just plain 9.
C, chapter 27.
Yeah.
How much charge is on a capacitor when the current stops at T equals 2?
Okay, how much current is on a capacitor when it stops charging at T equals 2? We were given this equation at the beginning of the problem. The current as a function of time is equal to 0.25 times T minus 2 quantity squared. Okay. This is the equation we have for current. I need to know charge. How do I find charge from current? How are they related to each other?
I equals V over I.
I is dq over dt. Calculus. It's the differential change in charge divided by the change in time. It's how fast your charge is flowing. Okay? If I want to solve this for Q, how do I solve this for Q? We do some physics math. Sorry, mathematicians. So I multiply both sides by dt. My dt's cancel. I get dq is equal to I dt. Get rid of the dq by taking the integral of both sides. Take the integral of dq, and I get q. I'm going to do something that my teachers never pointed out when they did. I'm gonna reverse the direction of these. So I'm gonna write this over here and this over here. Okay. It always confused me, but the integral of dq is just q, and that's equal to the integral of I times dt. Okay, so I just flipped the order that I was writing these, and I need to do it between 0 and 2 seconds because I want it after 2 seconds. Yeah. So then Q is equal to the integral from 0 to 2 of I, which is 0.25, times T minus 2, quantity squared, dt. I need to do this integral. Can I take anything out of the integral?
Yeah.
I can take some numbers out. What number? 0.25 can come out from. So this is going to be equal to 0.25 times the integral between 0 and 2 of T minus 2 quantity squared dt. Now I need to take this integral. Taking this integral, it's something raised to a power. So the integral of anything raised to a power is that thing raised to the power plus 1 divided by plus 1, right? The integral of x to the n dx is x to the n plus 1 divided by n plus 1. General format, this is on the equation sheets that you can use on the exam. When is the exam?
March 3rd.
Next week.
Yeah. Next Thursday.
March 1st.
Okay.
So, hope you've been keeping up. There's a lot to do. 0.25. Happy spring break. T minus 2 to the third divided by 3 between 0 and 2. So I plug in my endpoints. Most of the ones we've done previously to this, when you plug in 0, you get 0. Do you get 0 when you plug in 0?
No.
No. But you get 0 when you plug in 2. Make sure you're plugging in your endpoints. This is 0.25 times 2 minus 2 quantity cubed divided by 3 minus the other endpoint. 0.25 times 0 minus 2 quantity cubed all over 3. At this point, plug it into your calculator. If you can't get the right answer from this out of your calculator, come to my office hours, please. And when you plug this into your calculator, you should get 2 over 3. Coulombs. Should we let him in?
Well, I mean, he's in there.
Let's kick him out.
I agree.
Oh, you're not on your friend. Oh, you're
Don't come late.
No ice cream.
Any questions about this one?
No ice cream.
Oh,
Except for Purple Man.
Okay.
would this be fair game for a test?
Yeah.
Okay.
This is like 5 points on an exam.
Wait. Don't erase. Are you gonna post? All right, got it.
I'm recording. This video is going up on YouTube. Double whammy. Go for it. I'm actually probably going to lose subscribers on my YouTube channel because they're going to complain.
About what? Your unprofessionalness?
No, they're going to complain that it's like you think I'm sitting there in your class. Well, you are all sitting in my class.
It's not kind of obvious.
It's review for all of you. It's not for Zeke
Now you're
and
gonna lose
Sweden.
more people.
Yeah. That's fine. I don't need them. I'm not monetizing. Let's do number 45. 45 is quick. So 45, I have a bunch of resistors just connected in parallel. Okay. The picture that they draw looks a little different than the one I draw. I think that's what makes it confusing. I would draw it like this. The way they draw it makes it look like you might have a combination of series and parallel. You don't. These are all in parallel. I have a 5 ohm resistor. I have a 7 ohm resistor. I have a 9 ohm resistor. I can combine those all in parallel.
Yeah, show me how to do that.
If I'm in parallel, how do I add resistors? Flippy floppy way. So I have 1 over R, we'll call this 1, 2, 3, for resistor 1, 2, and 3, equals 1 over R1, plus 1 over R2, plus 1 over R3. 1 over R, 1, 2, 3, is equal to 1 over 5, plus 1 over 7, plus 1 over 9. 1 over R, 1, 2, 3. When you
Wait,
plug
but how do you combine them? Like in the drawing?
So when I combine those together, I've got one resistor out.
Okay, what if they were all in parallel? Or what if they were in series? Would it be like, and then down, and then down?
If I had something like this,
Yeah.
they would combine into one.
Okay.
I'm still combining them into one, except I wouldn't add them like this.
If
I would
all
just
three
add.
of them were in series, you would still combine them in one? Okay. So then why in some of them do you combine them into two?
In some, I combine in multiple steps because
Yeah.
they're not all in series.
Oh, or all.
And
like-
those ones, I have something that splits so that I have like, oh, that part is in parallel, so I have to add that part before I can add in series.
Okay.
So I have this 1/7 plus 1/5 plus 1/7 plus 1/9. What do I get? That gives me 0.45. If you are struggling with these, make sure that as I'm doing them up here, you're typing this into your calculator. Don't just straight up write down everything I say. That doesn't help all the time. Is this what the resistance is? No, what is the resistance? The group of people that hate Donald Trump. What else is the resistance? R123. Now I'm going to be flagged by the government. 2.2
Wouldn't that be something?
ohms. Okay, so that's the equivalent resistance that I have. What other things could I calculate? I could calculate the net current. How could I calculate the net current? I123 is equal to V123 over R123. Do I know what the V is?
Yes.
How do I know that? Given. How many volts do we have in here? We have 12 volts in here. I123 is 12 over 2.2. So what's the current? 5.45 amps. Okay. So that's the total voltage, total current going through this whole circuit. So I took it, I got it down to one resistor. If I go backwards, what am I going to? Am I going into parallel or am I going into series?
Parallel.
I'm going into parallel. What's going to stay the same in parallel, stepping back? Voltage is going to stay the same. So I know what V1 is. What's V1? 12 volts. Stays the same. I know what R1 is. What's R1? 5. I can find I1. How do I find I1? V1 over R1. 12 divided by 5. I1 equals 2.4. Thank you, Amin. How about V2? What's V2? 12. R2. 7. I2. V2 over R2. 12 over 7. 1.7. I3. Two ways we can find it. What are the two ways? Same way, V3 over R3. What's the other way?
Track.
How much current do I have total? 5.45. Minus 2.4, minus 1.7. What do I get? 1.3 amps. You can use either way. It's a good way to check all your answers. So I forgot what the question actually asks, but we've calculated everything you could possibly want to know.
I think that's what it asks.
Everything you could possibly know?
Yeah.
No, we know it. And knowing is half the battle. Insert clip from G.I. Joe cartoon show here. Maybe I don't even have to. Are you all old enough for G.I. Joe?
Yeah. A couple of episodes ago, really young.
Wow. You're all old. What are we talking about? Good. Good. Any other questions on number 45? Number 4 plus number 5. Nope. Let's do, well, somebody asked about 61C specifically. We're just going to do 61. Because I think it's combining a circuit. And I think that's useful to see again. And again, and again, and again. check my angles. Angles are still okay. So number 61. Okay. I'm just going to draw the circuit, and we're going to go through and just calculate everything. Okay? So number 61, we have a circuit that looks like this. We have a resistor. We'll call this R1 is equal to 2. And then we come up and we have these two resistors in parallel. And we go down, have a resistor in parallel. We'll call this R2 is equal to 4. And R3 is equal to 6. And I want to know what's the current and voltage in every single part of this circuit. Okay? If we are given, I think we're given at the very beginning that the total voltage, this is hooked up to a battery of 8 volts. Okay. First step, what's the first step? Can I combine R1 with R2? No, why not? Series with these things that are in parallel. So what do I need to do first? Combine the parallel parts. Yep. How do I combine parallel parts? Normally or flippy-flop?
Flippy-flop.
Flip-flop. So let's do 1 over R23 equals 1 over R2 plus 1 over R3. 1 over R23 is 1 over R2, which is 4, plus 1 over R3, which is 6. 1 over R23. What's 1 over 4 plus 1 over 6? I got one answer. Somebody in the back. Somebody in the back gets point. We'll do 0.41. We're going to round properly. We're going to do 0.42.
Dang it.
Okay. All right. So what does that look like? What does the circuit now look like? I have my R1. And then I have R23, because I've combined these parallel ones to be in series. So that's what I look like now. Yeah? How do I get R123? These are in series. Do I add them normal or flipped?
Normal.
Add them normal. So R1 is 2.
Wait, so when they're in series, do you draw it like this way, and when they're in parallel, you draw it down? When you're combining them, the chart, the lines.
These being side to side, that's because of the way it's drawn here. If it's drawn like this,
Oh.
it doesn't matter. I would draw it like this just to be consistent with how it was drawn before, but it
Okay.
doesn't matter.
Okay.
Question.
Yes.
For the resistance, are we going to do 0.42 over 1 or 1 over 5? Shouldn't it be 2.38 for R23?
Okay. Yeah. That was your question. So is this what the resistance actually is? What do we have to do when we flip?
1 over
Have to flip 1 over 0.42. So R23,
2.38.
2.4. So R123 is 2 plus 2.4. So R123 is 4.4. Okay. What else can we calculate here? I've got this circuit now. I've got it down to one resistor, R1, 2, 3. Let's calculate everything we can possibly know. V1, 2, 3. What's V1, 2, 3? Given as
Oh yeah.
8 volts. Given that at the very beginning. R1, 2, 3. We just calculated it. What is R1, 2, 3?
4.4.
4.4. What's next?
Current.
Current. How can I find current? I123 is V123 over R123. So that's 8 divided by 4.4. 8 divided by 4.4 gives me 1.8 amps. So I know everything I could possibly know about this one resistor. So what do I do now? Let's go backwards. I go backwards. I'm going from 1 resistor to 2 resistors. Are these in series or parallel?
Series.
These are in series. So what stays the same? So current is going to stay the same. So that tells me right away, I know I1 is equal to I123, 1.8 amps. Tells me that I23 is equal to 1.8 amps. I know R1. What is R1? 2. How do I know that? Given at the very beginning. I know R23. What's R23? I calculated it. It was 2.4 ohms and ohms. So how do I find V? How do I find voltage if I know current and resistance? V equals I times R. So I1 times R1. V23 is I23 times R23. Okay. I1 is 1.8, R1 is 2, so V1 is 1.8 times 2. What's that? 3.6 volts. What's V23 going to be? I23 is 1.8 times 2.4. 4.4. How else could I have gotten that? How much voltage do I have total flowing through each of these? 8 total volts. If I take 8 volts, subtract the voltage through the first resistor, I get the voltage through the second. I can check it. Multiple ways to calculate these things. I go back one more step. I'm going back and I'm turning it from here into here. I'm turning this R23 into these two. These two are in parallel. What stays the same in parallel? Voltage. So I know that V2 is the same as V23. V23 is 4.4, so V2 is 4.4. I know V3 is 4.4. I know R2 is 4. I know R3 is 6. So I2 is V2 over R2. 4.4 divided by 4. I2 is 1.1 amps. I3, V3 over R3. 4.4 over 6. I3 is 0.7. All my V's. I found all the voltages, all the currents. These types of problems, I don't think they're particularly difficult. I think they're time consuming. But if you follow this system, it all falls out. Yes?
Would you do the same thing for
62 C. So this is all of number 61. I don't remember what C specifically asked, but
The voltage.
there you go. That's everything. Any other questions on this? No? Okay, let's do 62A. Yeah.
How many points would it be on an exam if you just got the concept of like breaking the circuit down, like combining it?
It depends on how many points the problem ends up being worth, but that would be enough to get you a B on that particular problem. Yeah.
Do we have to work backwards once we get like the final answer, or like do we have to like do this second check? I guess.
You don't have to do this approach. You don't have to work forwards and then backwards. If you can keep everything straight as you're going and jump straight to answers, by all means do that.
Okay.
This is the approach I use because this is what I call it brute forcing. You're writing every single step down. I have found that this is ironclad. You're not going to get the wrong answer if you follow this. It might take a little while, but the more you practice it, you get really good at it, and you just fly right through and just keep writing, and you'll get the answer. I find this is better for people like me that are dumb and can't figure it out in their heads.
So you're smarter than Mr. Bubar. Then you can do it if he is.
Hey, my dad is Mr. Bubar.
Doctor.
I'm doctor.
For chapter
I have
27,
nothing to say.
what are we most likely to see on an exam?
For what? Chapter 27?
Yeah, like just like these two.
Anything? In 27?
What
Anything's
else
fair
is
game.
there besides?
Anything that's in the homework.
So you.
Hmm?
So you.
Yeah. That's the number 62. 62A was also asked about. So here's what 62A looks like. R1, R2, R3. Every time I say R2, it is so hard not to just say D2 right after it.
Yeah.
So hard. R1 equals 4 ohms. R2 equals 6 ohms. R3 equals 8 ohms. Let's calculate the voltage and the resistance through all of these.
They're parallel.
We were also given, I think, that the total voltage of the circuit is 12.
For 62?
Yeah.
8. No. You're right. 12 volts.
Good. I would hope so. Mr. Bubar would get it wrong. Dr. Bubar gets it right. 12 volts. How do I do this?
You
Find everything.
one
Find
over-
current and voltage through everything.
You do the flip flop.
I do the flip flop.
1 over R total equals 1 over R1 plus 1 over R2
Okay.
plus 1 over R3.
1 over R1, 2, 3 equals 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R1, 2, 3 equals 1 over R1, which is 4, plus 1 over R2, which is 6, plus 1 over R3, which is 8. 1 over R1, 2, 3 equals 0.54. Do we trust the mean?
Yes.
Yeah?
And then do
Okay. And what's R1, 2, 3?
1.85.
1.85. How did I get from this to this?
You did 1 over 0.5.
Convert by taking the reciprocal. So I flip 0.1, 1 divided by 0.54. And I get this. This is my total resistance. What can I use that to get? I? Okay. I1, 2, 3. How do I find I1, 2, 3? V1, 2, 3 divided by R1, 2, 3. V1, 2, 3 is 12. R1, 2, 3 is 1.85. So I1, 2, 3 is whatever that is. 6.5? Okay. 6.5 amps. So I was taking this whole circuit and I broke it down into one resistor, R1, 2, 3. Now I want to go backwards. I figured everything else I could know. I figured out the resistance, the voltage, and the current. Take it backwards. I go backwards, I'm in parallel or series?
Parallel.
I'm in parallel. What stays the same in parallel?
Voltage.
Voltage stays the same. So what's V1? 12. What's V2? 12. What's V3? 12. What's R1?
4.
4. What's R2?
6.
6. What's R3? 8. What's I1? 12 divided by 4. 3. What's I2?
2.
2. What's I3?
1.5.
1.5. Oh, that's a shame. It's like we were building up to something. What's I1? 3. What's I2? 2. What's I3? 1.5. Be better if it were 1. Yes, Wayne.
So just out of curiosity, so would you expect us to, like, say you gave us I, for example, and you gave us this parallel circuit, do we have to find like the amount of voltage? Like that, would that be like an example on the exam, or would you just always give us the voltage and
I could give you I's and then use that to find V's.
okay. So just be like expecting that also.
Possibly. Yes.
Now the whole
Couldn't you just find I for each individual resistor and add them all together to get the same result? In this particular instance, it's all in parallel.
Yeah.
Okay.
Multiple ways to do every single one. This is following through the process that I've been pushing on you,
Fair enough.
but you can always do it your own ways. The process I use works on everything. There are shortcuts for everything. Yeah. Any other questions? No other questions? No?
Can you keep that up if we're not doing more on the one?
I will keep this up. Let me see if I can get my video loaded.
Okay, let me restate that. Was the food good?
She in college. No.
It wasn't meant. They had one night was Indian food.
But it's something that people like
Especially Saturday, I always say my stomach doesn't feel well. So I kind of ruined the rest of this.
Like, I'll get to it. It's like 9 o'clock.
I had to eat it in the office.
Yeah.
Down there, you know what? It's funny.
Like that's what they did.
Well, so the wedding was, there were 2 weddings. They did an Indian ceremony and a Western ceremony.
it was just kind of weird.
So, Indian ceremony.
Kurt Williams got about 5 3D printers in our closet. We range anywhere from 1,000 parts a day to upwards of 10,000 parts a day.
Okay, we're gonna watch some TED Talk stuff. While you're watching that, I'm going to go print something up for you. This video is about something called quantum levitation. Okay, it's using superconductors. So the concept of a superconductor is something that you get really, really, really cold, and if you get it cold enough, you can make its resistance go down to 0. If you have 0 resistance, that means 0 ohms. That means that everything you create at one part of your circuit will make it to the other parts. There's nothing to dissipate your heat or your energy. If we could build power lines out of superconductors,